Okay, we are back again. Right now I'm checking my caches, but this is I think the second or the third time, to be honest. And this is actually why these things take, I think, way too long to make. So there's a few in between versions. I realized a few mistakes. So before I move forward, I would like to show those. Generally, it's about not linking the wedge attribute before sending it to wedge. So it was here, right? Like the first time I sent it, this wasn't here. So I simulated every building 12 times. But the output was same because the value never changed. So please don't do the mistake I do. Make sure you're wedging the variable so that we blast the correct buildings. The other thing was it was the fifth floor. So fifth floor was after we unpack it, I believe. But now we are blasting the individual points. And let me see if this is here. We can test it so I can show it actually. So at this point we have a just a point, right? Because we decided to blast the points. They are not visible. Let me try to make it a bit bigger. They are not visible, but they are here. Can I see them? Maybe. Okay. Let's make the background black. Yeah, because we were we need to offset these points a bit down, but we need to see the building first, and we were using the bounding box, but we were using it before loading the geo, and it kind of broke because bounding box of point is very little. So the buildings were floating on top. So now I just moved the fifth floor under instance. So this is let's load in the land is here. Okay. So one of the other things to be careful about is that our buildings must not be floating. So I sync them to make sure that those are basically sunk before simming it. So there's something for them to hold on to. Then we unpack and then we blast the glass here. Okay. The other thing was I also realized all my simulation versions were coming apart like real easy because I did left the wedge as I was testing it with the glue wedges, and it was like the first wedge 10,000 or whatever, and it was like breaking down like crazy. So for this building scale now 30 million is working just fine. So therefore the output. Now let's have a look at the output. For visualization purposes, we can do something like this. We have the animated land render, RBD land render. So this is the render node, the environment, right? So let's pull this down. Let's create another network box here. And this will be the buildings. Buildings. Buildings RBD. Okay, and let's make that darker color also. Okay, and then let's make another network box in this network box. So this will be the building RBD. So let's drop in a geometry node. We're gonna load back our caches and we'll try to kind of optimize them as well. So let's go buildings RBD. This goes here. We can then say buildings RBD render. It should go _R for all of these, but actually we are putting the render, right? Yeah, we can do the same. Excuse me. Okay, this goes here. Now let's get our paths, which are already here. So I'm just gonna copy these and I'm gonna explain on the other page in here. Okay, so here on the left I have my $hip geo rest RBD building. So what is this? What I did was this in the wedge. Here I made another branch from after the fracture, which is using the same wedge RBD, and there's this 7 extra dots here, which I'll explain shortly. It's a mistake, but it doesn't break the rig, but I'll explain. So from after the fracturing is finished, we make another wedge, because we only cache the points out of the simulation, so we need to capture the geometry at the rest position, so basically the fracture object, but with all the names and everything before we rotate it and move it. So what we can do is we can load this guy in here, wedge. It's called the wedge RBD because our attribute, because we are still using the same attribute to switch our buildings. So the values are same. It's pretty much like a copy of it. I think we might as well just do that, to be honest, but I did it separate. And then there's a rob geo, just like this guy, but this one is called rest RBD buildings, and the output format goes to here. It's the same. We're using always the same output, except this one is all going in one folder. Okay, so you can just copy the path here, and if you modify it, then you need to adjust when you need to load it back in. Then this is what this is baking is this. So let's go there. It's basically just baking this before simulation, 1 frame for each building. So the output becomes pretty much this. Let's load it in. And it's the building before simulation in its rest position, but it's also fractured. Okay, so next thing we do, let's go now to where we want. So now I have this folder which has 7 buildings as BGOs. Then I have this folder with 7 folders with simulations of 250 frames each. Okay, and now picture this. This is only 2.11 gigabytes for 250 frames, as opposed to otherwise what would have been. This is which building? This is building 1. So if I go to building 1, building 1 is 200 megabytes. So then we would end up with 200 megabytes times 250. That would be 50 gigabytes. Okay, so 50 gigabytes versus 2 gigabytes. So that's a pretty significant disk space save. So there's obviously, when you save from this space, you had a hit from another place, which means that we need to transform these pieces using these points. So it does take a little extra time to do that, and it needs the calculation. But since we're going to use Redshift, and since Redshift has Redshift proxies, we will end up optimizing to this as much as possible, and then to bake it to proxies anyway. But now, as it stands, this is what we have. For example, this is one building. We are out of the frame range. We're up to 1250. So this one, and again, we may end up, you may end up doing some test that says weaker, stronger, or randomize in between buildings. That's also another option. So let's put this on manual. So now we want to obviously load everything and to see how is our work looking. So and this is where we're going to do the loading, right? So we can do this in a few ways. Let's load in all the points from this simulation location using file merge. So what I do is that I'm gonna just select one, right? We did this before. My variable is slice, so this goes backtick $slice. Okay, and then you know how many we have 0 to 8, right? Which means, come back here, which means 0 to 7, sorry, 0 to 6. So load from 0 to 6. So now if I load these points as they stand, it's gonna load all of the points. Don't worry about this part much. We could freeze them, turn them into static, which we probably should do this actually, like I put a static zone here. Might speed up the simulations. Obviously I have a lot of pieces here that probably took some time to calculate. Speaking of optimizations, anyway, now these are my simulation points. So what I want to do now is that I don't want to load them like this. I want to load them as pack list primitives. So they all come, and if I go to the first frame, this display as full geo, does it work? No. Bounding box. So this should give me 1, 2, 3, 4, 5, 6, 7 packed objects. Okay. Now I want to do the same thing for my. This is just updated now. These are the point clouds. Now to do the same thing for my fractured buildings. Fractured rest RBD. Let's call that one. Rest RBD. Okay. So now what I want to do is load each one of them. So I'll copy this path, but I am going to make sure that this is load pack primitive, because I don't want to load everything all together. It may really slow down my report. So backtick $slice again. Okay. So now what I want to do is I want to get one, and I want to get the matching one from here. Now I want to do a transform piece. Okay, in a loop, so I can then go to the next building, and I can go to the next building, and I can go to the next building. So this is one way of doing it. It's good for preview and test rendering. It's not the most optimized way, but it's the best optimized way for storage. Okay, because it's gonna take so much less space. Now let me open my other scene, and I'll show you the RenderMan, the Redshift render scene that I ended up with, which gives me, which we'll set up as well. I basically, instead of doing that, I did this. I did a cleanup, and then I ended up creating the RS proxies out of it, which eventually gave me a big advantage when I need to render, because my render spin-ups were really fast. Okay, so this is our render scene that we set up, that we will set up. It's loading something. I still have these files. Interesting. I should remove them. Volume beading, it's combining the volume still. Don't do anything. It's doing this. Volume light, I don't want to see you, so I can work on it. All right. So then what I end up doing is that, because in that scene I have 10 buildings, and I end up creating 10 separate geos that uses the proxy paths which no more exists due to disk space issues. And then we will end up using and overriding the shaders, and this way I have some takes that I can say, you know, you become a environment math. We have trace sets, so I can, for example, say the glass here is never traced against, I don't know, some really far object, so because individual areas, right? So this was really helping out. And I did 10 volume simulations, which is doing the same thing. It's just like a clean, it was a clean way to render it. I was trying to get it done really automated, but that ended up being not so necessarily best way to work. And then I have my art context with, you know, some representative pictures with the flip books that I made, and Redshift nodes that ends up getting out these. Let's go back to the main take. That ends up rendering certain things, so we can do a little bit of comp here and there with the cryptomats based on shaders and or based on nodes. Now let's get back to our main topic. We are a little still far from this render setup part. So let's just do this one because it's pretty cool. So we can see I use that for flip booking as well. So like overnight you can flip book the entire thing and you can see how it's looking. Where do we begin? Okay, so this one is, it says time. Why does it say time dependent? It shouldn't say time dependent, because maybe it's because $S. Oh, because it's finding this, I think, just before .bg, and it's thinking it's, but it's not. Let's put a time shift so it doesn't load every frame. This should never load every frame. This should only load once. Okay, cool. Now, what I'm going to do is for each primitive, okay, we can say this in points. Okay, so this goes here. We can do this here as well. It's the same thing. So we fetched in one, right? So now let's create a meta import node. Okay. And let's plug this guy in here. Let's drop in an attribute wrangle outside. We can put it inside too, I think. Let's do let's say this blast keep processed. Let's call it keep processed. Okay, so this comes in as fetch input, so everything came, right? So what I want is that I want to put here a null. No, actually we don't need that. We have the iteration value here. Oh, we need to create another one, my bad. Create meta import node. Let's pull this guy to the right here, and let's call this. This is in PTC, okay? This is iteration. Okay. Because the numbers are lined up here, 0 to 7, 0 to 6, 0 to 6, so that mix. So when I keep 0 here and blast everything else but 0 here, the points should line up. So let's see. So on the iter, it's using the metadata, so then there's an iteration value of 0. So then I can say, let's create a using the gearbox, an integer here to use against the wedge value. Let's call it iter. Okay, apply accept. Now I'm going to copy paste this code. We are pulling the iteration data from this guy. Okay, so this one is now 0. It's going to be 0. So if I go here and change this to 1, this should turn into 1. Okay, and then basically point num, pt num. I think we can do that with the. Let's add an ID here. We may end up using it. I think I ended up using it at some point. So let's do that. Attribute wrangle. Just finding a little bit more optimized ways as I do this for the second time. Which this is in mesh in RBD. in REST RBD. And this is, I think, one of the biggest difficulties of making a big tutorial is that you have to redo the whole thing, and it's, trust me, very boring, but also fun. So integer at bid, I'll call this building ID at ptnum, because it's not going to change. So now we have a point attribute bid, and we're going to use it to blow it up. So basically it says if, right here I have everything, and now here is saying get this number value from here 1, and then blast everything but 1. Integer at bit if not equal to iter, which is this guy, and remove point, and that's pretty much it. And now we have this guy here, and we have this guy here, right? And if I go 2, now it's this one and this one, so they still line up. Right, okay, so now we can unpack this guy. And this guy. And now we can do our transform. So I'm going to say this is 6. When too much data goes in, things can get funky. Okay, this is number 6. Saving. Okay, we're going to introduce some frustum culling as well. All right, so we have this one, we have this one. Now we just have to do the transform pieces. Transform pieces. I think that should just do now. If you go to a different frame. Okay, and that looks about right. Now I go here. Okay, and if I look from a camera view, let's look at this one. It's too close. Let's go with 1. Basically now I can change to any other pass, and it should just do the what it should do with the rest of the buildings. Which means I will go to one of the last frames. Ooh, too close. Okay, because the camera is going. All right, so let's do this. Let's load in the environment so it's visible as well. And finally, I wonder if there's a collision issue here. This building is from here. Let's not have it. It's loading in from where? Here. Okay. We are missing the RBD pieces. So I don't need this one. I need this one. Then I need my did we not keep this? Oh, I wonder if I delete this. No, I didn't. No, because we need to activate testing. We don't want to activate testing. Ooh, did I put a control? Yes, here. Okay. So let's go here. Let's try to load the centerpieces as well. Okay, it's coming. It's not 0. Oh, what is this? Select wedge. No, wait a second. Let's load 1233. Why is this set to 0? Timeshift 2. Oh, then we had the time shift here too. We had a time shift as an offset, which we added some time ago. I believe I forgot it. Okay, not here, not here. Let's go and find it. Terrain RBD time shift tool. Frame. This is linked to itself. Okay, it doesn't matter. Let's just go $F. No, this is the first frame. Sorry, this is the rest frame. So it's gonna be 1000. Okay, and this is the simulated frame. So here everything should be transformed, and it crashed. All right. Good thing we saved. Let's open another Houdini. Small steps. I guess 1 hour of this entire tutorial will be crashing and reloading and fixing mistakes. Okay, let's go back here. And then load it on manual, so things don't explode. Let's go to Inferno. Let's load the last guy. I gotta say, it's quite remarkable for a file size of a Houdini scene that is 5 MB to create such scenes. The power of procedural, I guess, is really something we need to keep ourselves up to date with. This is a little behind where I would like. Let's check the recovery file. Okay, loading. Yeah, let me pause it. So you guys don't wait. Okay, this time it works. So yeah, so it's not floating. Good, because I was thinking maybe the collision wasn't working, but it's because we still have those edge pieces here. All right, so let's go back to this camera angle. Seems like our floors are collapsing. Obviously, we don't have local stuff due to certain constraints. Okay, let's go now back to our building section, and now the thing we're gonna do might end up this thing looking really cool. Let's adjust the light so we can see better. Spotlight, so we can have some shadows. What was it here? Yeah, look through light, spotlight. I'm gonna lock it so I can update my look like this. Okay, so we can get some shadows. Now let's go back to shot camera, unplug this. So this is what it means. Like basically you don't want to move your designated cameras. So when it's locked, you got this red. Okay. So now if I switch to high quality and why is my shadows not visible? Let's increase. Interesting. Well, the shadows. Oh, because is it because it's a packed object? I think that may be it. Actually, let me try something. Let's try unpacking this first. I think I've seen this before. Yeah, so that's what happens with the packed objects. You get a little limited viewport things. I didn't know this actually, but apparently it's a thing. We need a bit more detail though in the lights. So let's go 1040 14. I just double it. We can then, I guess, smooth it out a little bit. Can I do that from here? Not sure. I see bigger it is, more resolution we're gonna need. Well, we can. Okay. Not the best, but it's there. If we do that more. Okay, I'm just playing now. So let's do this thing, but if I unpack everything, it's gonna be a little bit on the edge. So I'm gonna unpack it, and we're gonna lose the shadows. All right. I should mention this, why this is a thing. I don't know. Let's go like this. Okay, so let's now say do every building. So it's gonna do this thing 7 times now, basically. Okay. This might take, I think, 2-3 minutes. I'm gonna pause the video again.